So yeah, this is whatever, Thursday the 10th, September 10th, field of training, going over what we did for commissioning to this same day. So this is the existing day tank. Previously we were talking about the white tank, which is the new day tank. Not much changed on this day tank. Very little changed. The only thing that changed was new control floats to signal the pump to turn on and off. No other hardware on here changed. The fitters did install a couple three-way valves where needed, just to tie in for generator 1's suction and discharge to go to the new tank. When we replaced the level probes, these are the old ones, which was on two different fittings. There's no fittings left on this tank whatsoever. So we needed to split this into going into two systems. So instead of having two probes with two floats on them, we combined them to have a single rod with 4 floats on it. We use these as the design, match them perfectly. So control point levels don't change. These were marks that were original, high level, pump off, pump on, low level. Those are still valid and set. We just simply replace the probes, put new floats on, and the like. But again, they are identical in function as these old ones. And of course, they look the same, at least on top, as the new system. Nice, shiny brass stem with a blue head on it. They have tags on them as to which one is which. This one, closest to the generators, controls the existing pump system or fuel tank number 1. The further one, closer to the wall, controls the new tank, new fuel system. And this is the leak sensor. We did not change the leak sensor. We just simply tied it in and pulled new wires. Previously, it was a cobbled together system that was wired through this junction box, going to that big box on the side with a bunch of weird random relays in there. So that much stays. The only thing that's left that is actually valid in that box is the wires from the boilers to signal saying to the pumps, hey, the boilers have started. Those wires pass through that box. But other than that, all the relays, everything are useless. They might not be dead, but they're useless. Again, just to quickly discuss the design changes on this. I mean, it's different design as to the white tank that has the open top and you can reach your hand in. This is just a double wall steel tank that's totally enclosed. So that intermediate area is just an empty void, and that's where that leak sensor is. Unfortunately, we can't see in there. We have to rely on the leak sensor itself to be protecting us. We still have, this one has a manual hand pump that was existing that can be used to pull oil out if needed for whatever reason. These two with the red stickers on them say fuel oil supply and fuel oil return from day tank 1. And you can see the three-way valves up top there to direct oil either to and from this tank or to and from the other tank. The pipe on the right of that so we're talking the pipe all the way here. This is the fuel oil return, the fuel oil supply to generator number 2. Fuel oil return from generator number 2 is going to be this one here. So it's these two pipes on the far end, and here are the supply and return feeding the second and new generator. Also just being controlled by the same three-way valves that we've discussed. Just by swinging those two handles at the same time, you will direct oil to and from each day tank, selecting which day tank you want to be used. The pipe that I have my hand on is the fill line that is coming from the pumps. Similar design. Each one of these level probes will signal to the different pump set to turn on, and each pump set has its respective solenoid valve that will open when so called upon. This smaller one is for fuel tank number 1. So when the fuel tank 1 control float signals I am low, and it's so selected on the panel, solenoid valve opens, allows oil to flow through. Conversely, if it's fuel tank number 2 that's in the lead, it's the larger one that's higher and in the back. Both come from the same place and go to the same place. It's just in parallel, allowing either one function, just giving you even more of that redundancy. Can we come to the back of the tank real quick? Cool. Okay, so this is the back of this black tank. This is the overflow for the tank. Much like the white tank is also a three-way valve. So we've got the overflow coming out of the tank, and then sending it back. This is to fuel oil tank number 1. This one is to fuel oil tank number 2. This is one of the 3 valves that will need to get changed whenever you're switching the systems back and forth between each other. These should always be lined up to whatever system is operational. Right now, it is tank number 2. As told by the flow arrow on the handle, if we flip it up, then if it were to overflow, it would go back to tank number 1. Now, it overflows back to tank number 2. Just a little added security so that if the pump were to stick on and keep running, overfill this tank, then it will overflow back to the same tank, and then you're only dealing with one overflowing tank. You're not dealing with an overflowing day tank and an overflowing storage tank, which would be a nasty, sticky situation. I think that's good for back here. So this is the system select panel, or as you'll see on documentation and wiring, a TV panel. Original intent of this was to control three-way valves, which I believe is why it called a TV panel. The effort of the control valves was altered during construction and design to remove motorized functions and make them manual ball valves. That's how we end up with the 3 manual valves, the return back to the tanks, the overflows from each day tank. So that's why you can see a plug here, is because it was originally designed a little different, but we've gone through a few evolutions of changes, and we have commissioned it all for the true intent of the sequence of ops. So of course we got a horn, we got a little display, silence button just for this horn. That's all it does, is just shut off the horn. These 2 lower switches, solenoid valves, day tank number 1 and number 2. they simply say off and auto. So if for some reason you wanted to say empty a tank and maybe clean it, you can flip that tank to off, and the pumps downstairs will not respond to a call for oil from that tank. That'll allow you to drain it down without the pumps fighting you and trying to fill it back up again. That's really all those do. They should just live in auto all day long. In auto just simply means listen to the control floats and do what they ask for you to do. Come on when they ask you to come on. This switch is really the most important on this panel, definitely, maybe even in the entire system. So this is the system select panel. Fuel oil tank number 1 or fuel oil tank number 2. Which tank do you want to respond to a call for oil? Whether that is on either day tank, the boilers, any response, all these things are going to be just sending out a broadcast to the both systems saying, hey, I'm low on oil, or I need oil to run. That's the whole point of having each day tank with 2 probes. Those probes are set for the same level, so they're going to see a pump on, call for pump at the exact same point in time. We got to tell one of those pump systems, hang on, don't work. The other one is going to respond to it. If we didn't have this switch, anytime a day tank went low, both pumps would turn on. If we didn't have this switch, anytime a boiler called to run on oil, both pumps would come on. That was not the design of the system. It was to be either or. So it's this switch and the three-way valves that would need to be switched. So whenever I change this back and forth between fuel tank number 1, fuel tank number 2, you also absolutely must change those three-way valves. The overflows and the system return. You'll see on the screen, might be a little difficult, on the left it says FT1 in standby, FT2 in auto. So it's just mimicking and reminding that, or at least acknowledging, let's say, that fuel oil system 1 is indeed in auto, fuel oil system 2 is indeed in standby. If either of these systems had alarms, they will say alarm instead of their current status. If either of these systems has a both pumps no flow alarm, meaning both pumps have tried to run, both pumps have failed to run, then you would get a fail. So the only 4 things you'll see on each of these is auto, standby, alarm, and fail. Alarm doesn't really go into much detail. You'll have to look at the BMS, or better, look at the actual pump panel outside. Fail would be both pumps have failed to get flow. So if you see fail, alarm, you probably can keep running off of that system. Fail, you're definitely going to have to switch over and investigate that problem. For what it's worth as well, this inside of here has the interface for the BMS. So this is where all of the panels for the fuel oil system connect to Johnson Controls BMS. So if there's a problem with that link, I would check and make sure there's power on this panel. If there's any sort of alarm on here saying day tank high, and any sort of alarm that might come up on here, the silence button, and then just hit escape on the screen, and that should be good enough. I think that's good for up here. Cool. Okay, guys. So this is September 10th, Thursday. Previously, we talked about the master panel. We went through the screens as to what settings to use, what settings not to use, and how to just navigate and get around and what to do. Today, we're going to go through the individual boiler screen and where things should be left, what each switch does, etc., etc. So I guess let's talk about the switches first, since that's easy. Series of switches, selector switches, and push buttons. Burner switch on, that's just simply enable the entire boiler or disable the entire boiler. Does not necessarily mean turn the boiler on and fire it. Because as you can see right now, the burner switch is on, but there's no demand because the boiler system is satisfied and the master panel is not calling for it. So for to get the actual boiler to fire, you need both this switch and an actual reason for it to run, meaning a demand or a load. Fuel selector, auto, and oil. Oops, sorry about that. We will talk about what that is in a second. Auto essentially means gas, but there is a national grid system that, according to a set temperature or whatever reason National Grid wants to make up, they have the ability to switch you to oil at any given time. If we were running on oil if we were running on gas right now, and it's a cold winter day, and the temperature drops, it would be, they might switch you over. I don't know exactly what the set point is for them and what has been negotiated. But they basically will shut off the main gas supply and force you to kick over onto oil. Right now that wouldn't happen because the gun is not in, but generally it would be best practice to keep an eye on the weather. If it's going to be a cold snap, a cold week, push that oil nozzle all the way in and make it ready to fire on oil. Or maybe push it in on your standby boiler and have it be your standby boiler where the first boiler will switch over and fail, but then your standby boiler will kick on and be ready to go in oil. I guess before moving on, if the boiler is actively running on gas and National Grid gives it the switch over to oil signal, the boiler will shut down first, then restart on oil. It won't be kind of a just fly into it and start squirting oil in. It's just going to shut itself down, say, all right, let's take a minute here and start back up on oil. It's not just going to flip it over on the fly. Important to remember, on oil, you have an independent gas line that is only for the pilot. That's never going to be interrupted. And you still, even on oil, use natural gas to light off. The next switch in line is the oil pump, which should always just be in auto. Or if for some reason you need to flip it on in hand, you can flip it on in hand. Maybe you're testing, maybe you just want to see what the pressure is. But just leave that in auto. DSS is your drive selector switch, which is drive off bypass. DSS, drive selector switch. This is talking about the VSD, variable speed drive for the blower motor. We generally leave it in drive, which is more or less automatic. Just going to be able to vary the speed of the blower motor as we see fit. We being the controller itself. So if it wants a little bit more air, it can speed up the blower. If it wants a little less air, it can slow down the blower. All off that VFD. It is a complicated piece of electronics. They do fail. They do just over time. They don't last forever, 10, 20 years, they fail. It's just the nature of the game. So a lot of people who care about their systems put in a bypass switch, which is just a regular old starter, as if you just put full line voltage to the pump. So obviously that's at 100% all the time now. We have indications on the screen that will say VSD on, VSD bypass, because it's very important for this computer to know, do I have control of the air coming in, or is it going to be at 100%? When we come in and tune these boilers for the first time, we have to build all of these curves, saying at 10% use this much gas and use this much air, and we tell the drive exactly where it should be at each stage of firing. When it's in bypass, we have to come back through and build our bypass curve, which assumes 100% air all the time, and then all we have is our gas valve to control that. So that's, if the drive were to fail, flip it to bypass, and you're just going to get 100% on the blower all the time. It's not as efficient electrically, it's not as efficient combustion and fuel-wise, so we like to leave it on the drive, and you get the best use of that. Bypass would be only in emergencies if the drive were to fail. CB780E reset is your next one in line. The CB780E is your burner control. That's the brains of things. This PLC is fancy, it's beautiful, it's nice. It allows us to see what's going on with the boiler. It allows us to control combustion. What it doesn't allow us to do, and what there's a separate controller in there, is actual safety limits and burner control. What I mean by that is monitoring for flame failure, monitoring for a few other things, actual gas valve opening. That all needs to be part of a certified package unit for the city. So that is your CB780E, which is essentially a Honeywell controller. That is what's doing all of your just general limits and burner firing. And then once that controller establishes, okay, I have a good, safe, reliable flame, it then releases it to the PLC saying, okay, I'm safe, you can take control and modulate and tweak things as you see fit. But it's also keeping a watchful eye on that flame scanner. So if this thing gets out of whack by the PLC, it says, nope, you're done, I gave you a shot, and shut it off. So if you ever see a burner control alarm, you must hit this button or else you'll never clear it, because that burner control alarm is on the Honeywell controller on the inside. This is the reset for that. It's not the reset for just any general alarm. You gotta hit that on the screen. Like say if the temperature went hot or something like that. You gotta hit silence, acknowledge, whatever. This last button is another city-state item, the auxiliary low water cutoff reset switch. So that's, you have two low water cutoffs here. One is a McDonnell Miller, and the other one is blanking on the name, but it is kind of electronic switch. It's got a little circuit board on the inside. This is just the reset for the auxiliary low water cutoff, manual reset. The McDonnell Miller is a physical button on the device itself. So that is a quick overview of switches, selectors, buttons on this screen. I would say this configuration, to the right, to the left, to the right, to the left, is standard. This should never really change day to day. Kind of coming up onto the screen, we see a lot of information right away on this boiler overview, pretty much the home screen. So we've got date and time. We've got up here the actual condition that the boiler's in. Right now it's just in standby. If it was running, it would say that. If it was off, it would say that. Moving down, kind of going left, we'll go just left to right as we pass through the boiler here. So flue gas, that's got a temperature sensor in the stack. We're monitoring the temperature of the stack going out. We have high limits on that. We have low limits on that. Generally, seeing a high flue gas temperature would mean that the tubes are dirty, whether it's on the fire side or on the water side. Oxygen percentage, that is the amount of oxygen that is leaving the boiler. We have a feature called oxygen trim enabled on this boiler. So we're closely watching the amount of excess oxygen in the boiler. Perfect combustion, using the perfect amount of energy to burn all of the fuel, you would have zero excess oxygen in going out. Everything's, oxygen in, burned, fuel in, burned, perfect. But obviously we're not in a perfect world. So instead of trying to aim for zero and then maybe accidentally going a little too lean, a little too pure on gas and possibly causing some sort of erroneous flames that we don't want, unburnt fuel leaving, we always want to keep that as 3 to 5 to 6, 8% of extra oxygen that's leaving, which means that we're pretty much guaranteed to have all of the fuel burnt that we can. So oxygen trim is just simply varying a couple of devices to keep that the computer will do that on the fly, just modulate controllers, VSD speed, just to maintain that perfect amount of extra oxygen that we set it at. ISO valve partial, isolation valve partially open is what that's really trying to say. That is on the water leaving the boiler and going into the supply header for the system. We keep that isolation valve partially open, that way the boiler stays hot. This boiler has not ran in at least overnight. Has not ran at least overnight, but it's still maintaining 187 degrees. And that is because the water from the system is flowing through just a little bit, keeping it warm to the touch and ready to fire if it needs to. Efficiency, it will be a educated guess as to what the actual flame efficiency is. Flame efficiency, not necessarily accounting for water, it's just your flame efficiency. And that should be somewhere around 85%. Supply water, which is leaving the boiler, and the set point. That set point could be a little misleading. Set point there is only on local control. So auto in local control. We can touch more on that a little bit. Current status, boiler off. Remote lead lag, which is perfect. That means it's listening to the master panel. It's going to do whatever the master panel wants it to do. VSD on. Again, that is just according to the drive selector switch. Is it bypass? Is it on? That's what you got right there. Moving down to this chunk, we got combustion air, which is just basically air in the room. A little balmy, 91 degrees. Blower motor, so the speed of the blower motor. A fuel type, natural gas. If we switch it to oil, it'll say number 2 oil. Firing rate, so how hard the boiler is working. 0% would be quote idle. 100% would be max firing. This little black box is just a little pretty indicator. When the boiler is firing, you'll see a big flame, yellow and red, just shooting in. You'll see a little blue and yellow when it's just on pilot, and then when it establishes full flame, you get the full flame. And then this is just a little ID tag, just saying South Beach Psychiatric, boiler number 2, how many hours it's ran, and how many times it has cycled. Coming down here, these are our options as to where we can go from here. Of course, we have alarm silence. Any alarms that would pop up would be a big red box down here you'd have to acknowledge. Say, even go here. we've got the bell, and then we have the exact alarm that came through. Oil drawer switch. So I selected oil to be my fuel, but it knows that the oil gun is not inserted. So it's sending me an alarm. So I was able to hit silence, and then I can hit alarm acknowledge, so meaning just do this one, or acknowledge all of the alarms, because sometimes several alarms come through at once. So oil drawer switch alarm, this 1936 is not necessarily like a lookup code. That's not going to be in the book anywhere. It actually is designed to match the cycle. So 1936 is what cycle it is on. So it helps you when you're looking through the alarm history just to figure out, okay, well, all of these happened on the exact same cycle. They're probably related. Or you can say every time the boiler tries to cycle, I get the same alarm. Or maybe it's every 5th cycle we get an alarm. It just helps you with your troubleshooting. Boiler limits open, and so forth. So even though I acknowledge the alarm, it's still flashing at the top because it's active. I release the active state and it goes away. And hit that button for good measure. So of course we can pull up the history in the bottom right corner and see all of these alarms. So you can see a couple different times when I accidentally hit it earlier today, 11:19, also in the same boiler cycle, 1963, and then again 20 minutes later in the same cycle, because the boiler has not gone through a cycle. Then you've got page ups, acknowledge, clear the list if you want, and so forth. We'll go back to the boiler overview. You've got boiler control, firing rate, and screen select. Going into burner control gives you a little bit of information as to what's going on. A little graphic of what that actual burner control block, the Honeywell, looks like. It looks just like this on the inside. It's got lights, tells you what condition you're in. You're in standby. Are you driving to pre-purge? Are you holding for pilot? Whatever actual thing the boiler's doing, it's going to tell you right there. You got a light for pilot. When the pilot's lit, you've got a light for when main flame has been established, and then you've got a light for an alarm. These green boxes, burner switch on, you can see that. Limits, limits will again be things like your oil drawer switch if you're in oil, your high temperature limit, things like that. Load demand, meaning do I have a call for heat? And then external interlock closed. That's kind of a key one. That is anything external to the boiler itself, which is going to be your gas detection system for the room and your damper makeup air system, all of which Johnson Control is controlling. So essentially we send a signal out to Johnson Control and we wait to make sure that they more or less give us permission to run. So if we don't have this light, something with their system is not quite right, whether that's the damper's not open, maybe the makeup air fans have failed, or maybe it's sensing that there's carbon monoxide in the room. ALFCO is just more the demand from the master panel there. These are a little bit more advanced of just information that more the techs are more used to looking at and reading, and just this is a good homepage for them to come in and see what the problem is. So back to boiler overview, we can go into firing rate. This gives us detail and control over how hard the boiler is firing, if there is demand, if all these other situations are met. Again, it says remote lead lag. That is good. That is where it should be. That means it's going to listen to the master panel and be a part of the sequence. Little confusing because we have 3 options: remote lead lag, auto, and manual. This auto is considered local, and it's going to try and start on me if I do that. I don't like that. Auto is listening to its own controls. Auto is listening to this set point. Generally, we don't want that. We want it to listen to the main control panel. Manual, of course, would be still contingent on the demand or the set point in terms of off and on points, but we have control over the firing rate output. Again, just detailing oxygen levels in the flue and the position of the isolation valve and so forth. We can scoot over from this page and see a little pretty detail on the blower drive. Just speed, amps, kWs, if there's any alarms or faults. If there is an alarm or fault on the VSD, this is the button to do that reset. Just to kind of keep you coming back to the boiler overview, we can go into screen select. Now this is kind of where, like a menu page, screen select page, you can get to a lot of the same panels that we just were talking about: blower, firing rate, burner control overview. But these all are kind of in-depth set points and things that are not really, these three are your main. And we'll talk about this one here, isolation valve. So this again is kind of part of why it's so critical to keep it in the master panel. Keep this burner switch in the on position and keep it running off the master panel. Because what happens when I close this burner switch, it starts to close its isolation valve. It says, okay, you don't need me. I'm going to close my isolation valve, and just because I don't need to stay warm anymore. But leaving this burner switch in the on position says, hey, I might need you to run at some point. So it's going to automatically open its isolation valve to a predetermined set point to be just enough to keep the boiler warm. And then when it goes to fire, it will release it to fully open. Sometimes if the boiler is still cold and it's kind of in a warm-up phase, it will be firing with the isolation valve partially closed, just to kind of slow the water down and heat the boiler up a little faster. Again, you do have a manual operation, so you could open that fully if you wanted to, but definitely recommend to leave that in auto, leave the burner switch on. That way it stays partially open and your boiler stays nice and hot all the time. We'll quickly talk about, well, some of these are a little safety oriented. It won't let you get into screens, or at least if it won't let you get in, there's something important in there. Sometimes it'll let you get to combustion screens, but you won't actually be able to change anything without entering a password. So that password will get entered in up there if you know it and if you need it.